Lesson 5.3b, perimeter and area of similar figures. So we studied similar figures yesterday. We studied how to find missing sides of similar figures. Now we're going to talk about something just slightly different. First of all, the ratios of similar figures, if they have a scale factor of A to B, so 2 to 3, or 1 to 5, or 1 to 2, so we had all different kinds when we were looking at those, then the perimeters have the exact same ratio, A to B. They have the exact same ratio. However, if you have two figures that are similar with that same scale factor, A to B, the areas have the ratio of A over B squared. I want to write that another way also. The area ratios would also be A squared over B squared. So it's going to be important that you remember the difference. Now I want to ask you something. When you have to figure out the area of something, how do you label it?
Square feet.
Square feet. So hopefully you'll remember this by knowing for area, it's square units. So area, the ratio is squared. Hopefully that'll help you remember. Okay, so let's look at the example that they have done for us first before we go do examples at the bottom. It says, for the pair of similar figures, find the perimeter of the second figure. If you're looking at this, these two rectangles have a ratio of 8 to 5. That's what we were doing yesterday, writing the corresponding sides. So 8 to 5, it kind of follows along with our big to small. Well, the perimeter of the biggest one is known, it's 24. So see what they've done? 8 over 5 equals 24 over x because the perimeter is in the exact same ratio. So you do your cross and x equals 15. The perimeter is 15. All right, now let's look at these two that they've done down here. What you need, Dylan?
If you scroll up on the 5 or 8, you could just find out what 8 times 3 is 24, and then you take 5 times 3, which is 15.
Okay, but that's really what you're doing when you're solving the proportion. Yep, true. That's what you're doing when you're solving the proportion. 8 over 5 equals 24 over x. You're really doing that. Because some of them aren't going to be that simple. Some of them aren't going to be that simple, and they're going to have decimals in them or numbers that don't come out nice and even. So you got to know how to do it with all of them and practice with the simple ones, and then when you get to the harder ones, you'll know how to do it. Okay? All right, let's look at number 1. It says the picture frame, there's a picture frame. Pauline made a picture frame to give to her friend as a gift. The length of the frame was 5 inches and the perimeter was 16 inches. Pauline decided to make a similar frame with a length twice as long as the first one. What is the perimeter of the new frame? Okay, so I'm going to do it this way. I'm going to draw these, okay? She's had a smaller picture frame in which the length is 5 inches, and we're told that the perimeter of that one is 16 inches. Well, now she's going to do a new frame that's twice as long. So how long is it? 10 inches. So we need to figure out the perimeter. So we're going to set up this proportion. We're going to set up the proportion, and we're going to do, we're going to stick with big to small that we've done all day. We're going to go small to big, left to right, what?
Big to small,
Small, big. Let's do small, big. It's good to mix it up a little bit so you can make sure you know what you're doing. So fraction bar equals sign fraction bar. small to big. So the ratio of these two, 5 to 10. The perimeter of the small is 16. We don't know the perimeter of the big, so I'm going to say P. Once you get all the spots filled in, we're going to cross. So 5 times P equals 10 times 16. 5P equals 160. How do you solve? What's the last step, Liam?
You would divide everything by 5, and you would get 32.
32, and we should label that 32 what?
Square feet, or inches, square inches.
Is it square inches when it's the perimeter?
Oh, no.
It's just 32
Inches.
inches. Make sure you label if you're finding the perimeter or any length. 32 inches. Questions about that? Okay. Now, on number 2, it says Brienne put a triangular shaped piece on her quilt with one side 6 inches. The area of that triangle is 36 square inches. She placed another similar triangle next to the side corresponding to the 6 inches as 3 inches. What's the area of the smaller triangle? So we are talking about area this time. So if I do a triangle, one side is 6 inches, and this one has an area of 36 square inches. Now it says that she has another one and the corresponding side's only 3 inches. So I kind of wish I'd have made the first triangle a little bit bigger, because now I got to go smaller, and it's already pretty small over there, but we're going to do it. So we're going to make a smaller one. And now this time this is 3 inches, right? So I got to figure out the area of this one. So I'm going to say, are we going to go big to small or small to big?
All big.
Small, big. Fraction bar, equal sign, fractions bar. Small to big. So the sides that match, what gives us the ratio is 3 over 6. Why aren't you writing anything down? You're not writing anything down. 3 over 6. And we've got 36 over X. Oh, I sure did. I got distracted. Okay, 3 over 6, and then we're going to go A over 36. We're going to cross. I'm going to run out of room below, so I'm going to come up here. I'm going to go 3 times 36 equals 6 times A. 108 is 6A. Xander? Yeah, divide by 6. And A equals 18. And how should I label that 18, do you suppose? Square inches. 18 square inches. 18 square inches. So the area over here is 18 inches squared. Okay, so you're setting them up. You find the ratio of one set of sides, and then you're going to figure out area, which is in square units, or perimeter, which is in the same ratio, and that should be good.